I just talked about factoring the difference of two squares. And I wanted to add on a little something. As you can see, this was taken at a different time. It's much warmer now. Power is back on. And so yeah, we're going to record a video talking about special types of quadratics. So let's just look at this example. X squared plus 4x plus 4. Okay, now you could factor this the any old way, right? Just how we factored in the past, saying that the sum of my two numbers needs to be 4 and that their product needs to be 4 as well. Whatever I'm factoring this out into. So x squared plus 4x plus 4, well, numbers that sum to 4 and multiply to 4, would be 2 times 2 or 4 times 1. 2 plus 2 is 4, so this looks like the moneymaker. And this would just factor into x plus 2 times x plus 2. Now we'll take it one step further. What happens when you multiply something by itself? Well, we call that squaring the number. So this then would be x plus 2 squared. So you start here and then you factor it out and we end up with x plus 2 squared. Now the pattern that I want you to see here is that if this last number is a perfect square, so some perfect squares might be, I don't know, like, 4 or 9 or 16, 25, 36, right? 49, 64, 81, 100. Probably those are the ones that we'll be looking for the most often. But if you see one of those numbers, then that should key you off and think about, okay, is this the sum of whatever the square root of this is? So since 2 times 2 is 4, well, 2 plus 2 is 4 as well. And that'll key you off that this is an x plus 2 squared. Now, that's all well and good because it's actually quite easy to factor by itself. But what if you're given something like this? 25x squared plus 70x plus 49. Okay. And just like in the last example, you could factor this using methods you've learned before. You could use the big X method, right? And say, okay, the top is 25 times 49 and the bottom is 70. And go from there, right? Finding two numbers that both add to 70 and multiply to whatever this very large number is, and then factor from there. But of course, that's a lot of work. So two things should key you off there, just like I just wrote out all of these perfect squares. Here I see that I have a perfect square at the start with 25 and a perfect square at the end with 49. So I should be keyed off that whatever this 25x squared is has to be the product of two numbers. And 25x squared is actually kind of nice because what multiplies to 25? Well, 25 and 1 or 5 and 5. So if I'm creating whatever I'm factoring, here I'd have 5x times 5x because 5x times 5x is 25x squared. And then what times what is 49? Well, 7, right? The square root of 49 is 7. So just knowing these is really handy, but you can also kind of play around with the numbers a little bit. Okay, so now I have 5x plus 7 times 5x plus 7. And, well, that would be the factored form, but can I check? Yeah, I certainly can, right? 5x times 5x is 25x squared. 7 times 5x is 35x. 5x times 7 is 35x. And 7 times 7 is 49. So then, after combining like terms, I get 25x squared plus 70x plus 49, which is what I started with. that means that my answer is 5x plus 7 times 5x plus 7. Or, I guess really I should write it like this, right? Because remember, if we have something multiplied by itself, that would be 5x plus 7 squared. Okay, so that is, yeah, that's really the key here, is to notice that you've got two square numbers, 25 and 49 in this case. And then the square root of 25 is what goes in front of x, because that's what's in front of x squared. And the square root of 49 is what goes after that 5x, because that's what we've got right here. So it takes some work, and there's definitely patterns to recognize here. And that's so much of what algebra is recognizing number patterns. So if you can recognize these patterns, that'll be a really powerful tool that will help you in factoring these kind of special cases where we have square binomials. So I hope that helps. I'll see you in the next video.